Welcome back to another LeetCode with me session, where I take random LeetCode problems and solve them completely on the fly, no prep, so you can see kind of my thought process and any mistakes I make, how I go through it. So the last time I made this video, I got a lot of very interesting comments thinking I'm literally blind or gonna blindfold myself or something, which was very entertaining to me because I have literally made, what, like 7 of these? And never once until now had I had to clarify that when I say I'm solving problems blind, it just means I haven't prepared in advance. But with that out of the way, let's get into it. Let's do a random one. Range sum of BST. Easy. How is it that I always get the easy ones on the first try? Given the root node of a binary search tree, 2 integers low and high, return the sum of values of all nodes with a value in the inclusive range low, high. Let me remind myself what a binary search tree is. So it's like between 7 and 15. 10, okay, we want to look on both sides of that. So we have 5 and 15. 15 is where we only want to look on the left side, but we have nothing on the left side. 5, we want to look on both sides. Okay, so with a tree, do we want to go breadth first search or depth first search? It doesn't really matter the order because we just want the sum. So I would probably go with depth first search, I think, because like if we go, okay, 10, we want, actually no, let's go with breadth first search because we want to add everything we want at every level kind of thing. We want to add 5 and 15. Okay, then when we look at 5, oh wait, no, I forgot. Low is 7, right? I was only thinking about the high is 15. So we go to 10, low is 7, high is 15. So those are on both sides of 10. We go to 5. We don't include the 5 itself because it's lower than the low, and we only go on the right of it. Since 5 is already too small, the left node of 5 is going to be too small for sure. As for 15, we do want to see that, and then that is the highest of where we want to go, so we don't go to the right node, but we do want to go to the left node if it exists, but it doesn't. Okay, that seems more like a breadth first search pattern. So let's just implement our basic BFS setup. So we want to have a visited set and queue. I'm just going to call it a queue. I want to start at the root. We're just going to put the root in the queue. And then I guess we just go through the queue. So for example, let's take an example where it's not in the middle. So for example, we have, goodness, okay. For example, we have a low of 6 and a high of 10. Let's say we have this. Actually, let me back up. Let me implement the rest of the BFS first. So while we have a queue, we pop the first element to be our current, and then we add the left and the right. So how do we do that? If the current value is, so let's think about this. So let's say we're popping 10. Do we want to add the left? We want to add the left if the current value is greater than low. Q append current left. And then if the current value is less than high, we want to append the right one, right? Let me just run through this. So current value is greater than low. It is. We append this. Now let's say this. 5 is greater than low. No. Is it less than high? Yes. So we append 7. And then we also want a sum. We can't call it that, but we do want a sum. And if it is more than low and it's less than high, oh, it's an inclusive range. So let's say greater than equal to, then our equal to, then we add the current value to the sum. And I think that should be it. Oh, also because this is a tree, we don't need a visited. I think that should be it. Let's try it. Oh, we forgot to return it. Of course we did. Yep, I know. I'm not paying for it. Right. Current value is more than low, and the current left exists. And current left, actually, we're just gonna put this first because it's easier to do. And then current right exists. Now let's try. All right, that works. Let's try it. Great. we got it. And yeah, that looks like pretty much a good solution. I'm just gonna run it one more time just to see if we... What on earth? That is not the direction I was hoping the non-determinism would go. Yeah, whatever. Good enough. Cool. Okay, that's good. Okay, before I go on to the next problem, I'm just gonna give a quick shameless plug to my newest project. So I'm currently building AlgoPattern, which is like a Duolingo but for LeetCode. Right now it's in early beta, and what you get is daily quizzes where you have LeetCode style questions and you just have to pick which pattern you think should apply. So like sliding window or breadth first search or merge intervals, or things like that. So if you want to check it out, I will leave a link to the landing page in the description. Okay, let's go on to the next one. So like, why would you give me a random one that I can't do? And again? Another easy one? Okay, I mean, I guess that works. Okay, detect capital. We define the usage of capitals in a word to be right when one of the following cases holds. All of the letters in this word are capitals, like USA. All of the letters in the word are not capitals, like LeetCode. Or only the first letter in this word is capital, like Google. Given a string word, return true if the usage of capitals in it is right. Let's think about our cases here. The first letter can either be capital or not, or lowercase. If it's lowercase, everything else needs to be lowercase. If it's capital, either everything else has to be capital or everything else has to be lowercase. Let's see. If the first letter of the word is equal to the first letter of the word in lowercase, then return word is equal to word lowercase. Otherwise, it's the first letter is capital. So we can either have it be all capital or we can have it be all... we can either have it all lowercase or we can have it all uppercase. No, sorry. Everything's starting from after the first letter. All the slicing might not be optimal, so let's just see. Never mind, we're good. Wow. Okay, that might have been the fastest LeetCode with me problem we've done. This is definitely the fastest LeetCode with me session we've done. And last time I think there was an easy problem that was very quick, but this was probably the fastest session itself, just because I got 2 easy problems back to back. All right, well, if you enjoyed that, I do these every other week mostly. And otherwise, I'm sharing my journey as a computer science student, building projects, working on things, and just kind of sharing my journey. So if that sounds interesting, feel free to subscribe and stick around.